When we apply an element on an enemy in Genshin Impact, the only thing that we see is whether or not that element was applied. To us, it appears as a binary state of matter. The element is either on or it's off. But what's actually going on under the hood is that we apply a certain amount of that element, and that amount gradually decays over time. When we trigger a reaction against that enemy, we have to spend some of this amount to fuel the reaction. This is the basic principle that governs how reactions work in Genshin Impact, and the larger system of rules and behaviors related to reactions is known as the elemental gauge theory, or sometimes gauge unit theory. Before we get into the details, let's first define some terminology. From this point on, when I apply an element on an enemy that isn't already afflicted by an element, I'll refer to that as the aura element. When I trigger a reaction against an enemy that already has an aura, I'll refer to that second element as the triggering element. It's also worth mentioning here that Geo and Anemo cannot apply auras on enemies. They can only be used as triggering elements. Now let's really get started. Going back to the elemental aura, we can think of this decaying meter as a kind of gauge that measures how much of the aura element is remaining on the target at any given time. The initial value of this gauge depends on the attack that we use to apply that aura. Every elemental attack has a predefined number of gauge units that determines how much of its element it applies. Most attacks in this game apply one gauge unit of their element. We call these 1 unit or 1U attacks for short. Then there are some attacks that are categorized as 2U attacks, which sensibly apply twice as much of their element as 1U attacks do. And even fewer are those in the 4U category, which apply 4 times as much. With the introduction of Nahida, we even have a 1.5U category, which currently only includes the Tri-Karma Purification proc of her skill. When you apply an elemental aura from multiple sources, they don't stack on top of each other. Instead, it simply refreshes the aura using whichever one has the higher gauge units. Now, even though we're using 1, 2, and 4U attacks, you might have noticed that in my illustrations, the elemental aura gauge doesn't quite fill up to those values. This is to account for something known as the aura tax. The aura tax is a rule that reduces the amount of gauge units by 20% if an attack is being used to apply an aura. In this example, I'm using Kaya's skill to apply Cryo on this Ruin Guard. Kaya's skill is a 2U attack, which normally applies 2 gauge units of Cryo. But since it's being used to generate an aura, the amount of Cryo that actually gets applied is 20% less, or 1.6 units in total. As we saw in the introduction, when we apply a triggering element onto a target that has an aura, it triggers a reaction and consumes a portion of the elemental aura gauge. As you might guess, the amount of gauge units that are consumed, again, depends on the gauge unit of the attack that triggered the reaction. Lisa's normal attack is a 1U attack, so when it triggers a superconduct reaction, it reduces our aura by 1 gauge unit. The remaining amount continues to decay on its own until the aura is depleted. Beidou's skill is a 2U attack. Since this is greater than the aura gauge units we started with, this superconduct reaction consumes the entire aura. If you're familiar with card games or most other games that use spells, one way I like to think of it is that the elemental aura is like a resource or mana bar. Every time we want to trigger a reaction, we need to spend some of that mana. Just like how different spells can cost different amounts of mana, each reaction also has its own reaction cost. The reaction cost, also known as a reaction coefficient, is a factor that multiplies how much aura is consumed when you trigger a reaction. I use superconduct in all the examples I've shown so far because it happens to have a reaction cost factor of 1. This means that the number of gauge units consumed by a superconduct reaction is just equal to the gauge units of the triggering attack itself. But if we instead look at Pyro Melt, for example, sometimes known as a forward melt, its reaction cost factor is 2. This means the number of gauge units consumed is 2 times the gauge units of the attack that triggered it. Yanfei's normal attack is a 1U attack, which normally applies or consumes 1 gauge unit of Pyro. But because of the reaction cost factor of Melt, her normal attack ends up consuming 2 gauge units and completely depletes the Cryo aura. A reverse melt, on the other hand, has a reaction cost factor of 0.5. This means triggering melt with a cryo attack only consumes half the gauge units of that attack. Eula's skill is also a 1U attack, but since we're using it to trigger a reverse melt, we only consume 0.5 gauge units of our aura. This leaves plenty of that pyro aura for potentially another reaction. Of course, a forward melt has a higher damage multiplier than a reverse melt, but being able to leave some of that aura for another reaction can be a worthwhile trade-off. This big difference in cost between a reverse melt and a forward melt is actually one of the reasons why most melt teams use a cryo damage dealer with a pyro aura applier, instead of the other way around. Even though a forward melt would deal more damage, the high cost factor of these reactions usually ends up consuming the entirety of our aura bar. This means if we want to trigger another forward melt reaction, we need to quickly reapply a cryo aura on the enemy. And if you're already familiar with the concept of ICD, you'll know that reapplying an element quickly isn't always easy to do. On the other hand, if we stick with just reverse melt reactions, it's much easier to maintain the pyro aura on the enemy because this reaction is much cheaper and doesn't consume nearly as much of our aura. Since both Kaya and Rosaria's bursts are 1U attacks, even if one of them triggers a melt, it only consumes 0.5 gauge units, and we still have enough pyro aura left over for the other one to trigger another melt. Here's another example with Bennett and Chongyun. Bennett's burst applies a 2-unit pyro aura on the enemy, and Chongyun's burst, which doesn't have an ICD, is a 1U attack that hits 3 times. Each hit of his burst only consumes 0.5 gauge units when it triggers melt, so even after the first hit triggers a melt reaction, we still have plenty of pyro aura remaining for the following hits to trigger their own melt reactions. The same philosophy applies to Vaporize as well. This is why you typically see a pyro damage dealer and a hydro aura applier in teams like National and Hu Tao. The relatively cheap cost of reverse Vaporize reactions is actually an important factor in allowing Hu Tao teams to function properly. Since Hu Tao is a melee character, she's forced to use a normal attack before each charged attack. This normal attack does trigger Vaporize and steal some of our hydro aura, but since it is a reverse Vaporize, it only consumes a small amount of gauge units, and we still have enough hydro aura left over for her charged attack to trigger another Vaporize. Of course, ICD plays a big role in deciding which element is better suited for the aura, since we ultimately need the aura element to be applied as frequently as possible. But like we just saw, elemental gauge theory, and specifically reaction cost, is also a major factor in making these teams work, and also making them more forgiving. As complicated as elemental gauge theory is, I'm hoping that being able to visualize the elemental aura and the gauge unit consumption helps to make these concepts feel less abstract. You might be surprised to hear though that the game actually does have a visual representation of elemental aura. It appears in the form of elemental shields. An elemental shield can just as well be thought of as an elemental aura, and now we can apply everything we've learned up to this point to shield breaking as well. Let's take this Hydro Abyss Mage for example. First, I use a 2U Pyro attack. This triggers a reverse Vaporize, which has a reaction cost factor of 0.5, which means we consume 1 gauge unit of the Hydro Aura, which in this case is just a Hydro Shield. Next, I use a 2U Cryo attack. Freeze has a reaction cost factor of 1, so this consumes 2 gauge units from the Hydro Shield. Finally, I use a 1U Dendro attack. A Dendro Bloom reaction has a cost factor of 2, which means this one also consumes 2 gauge units off of the shield. This is a good place to mention that the elemental shields used by Fatui skirmishers, sometimes referred to as elemental armor, have their own set of reaction costs, and they are quite different from the ones we've been using so far. So if you ever notice that their shield weaknesses are slightly different from most other shields, this is the reason why. Putting this difference aside, you'll notice that all the concepts we've been learning about so far all behave in exactly the same way even when we apply them to shield breaking. The great thing about understanding elemental gauge theory is that it can be applied not only to the reactions that you create within your own team, but really anywhere else within the game. And on the topic of open world interactions, let's talk about Frozen next. Frozen follows the same concepts that we've learned so far, but one other aspect of it that's related to gauge units is how long the freeze lasts. The exact formula for calculating the freeze duration is a little complicated, but the main thing to take away is that the duration is proportional to the lesser of the 2 gauges that were used to trigger Frozen. For example, here I'm using a 2U Cryo Aura and a 1U Hydro trigger. Between these two, the 1U Hydro attack has fewer gauge units, so the freeze duration is calculated based on that. In this example, I'm using a 1U Cryo Aura, and if we remember to account for the aura attacks, it actually only applies 0.8 gauge units of Cryo. When we trigger Frozen with a 1U Hydro attack again, this time the Cryo Aura has fewer gauge units, so the freeze duration is calculated using that amount. When we apply this to freezing bodies of water, you can consider water as having an infinite hydro aura, so the cryo attack that triggers the freeze reaction will always be the lesser of the 2 gauges, and the freeze duration will be purely based on that. A fun fact that's related to this is that Kaya's skill is normally a 2U cryo attack, but when it's used against water, it becomes a 4U cryo attack, resulting in a super long 9-second freeze. So if you ever wondered why Kaya's ice bridges last so much longer than everyone else's, this is the reason why. Where elemental gauge theory starts to get really interesting is when a target is afflicted with multiple auras at the same time. While this isn't typical for most reactions and elements, it can happen with Electrocharged, Burning, and Quicken. Let's start by looking at Electrocharged first. Instead of consuming the aura all at once, Electrocharge allows both Electro and Hydro to coexist as auras at the same time. While both elements' auras are still up, Electrocharge deals 1 tick of damage per second and consumes 0.4 gauge units off of both auras with each tick. After either one of the auras is depleted, Electrocharge stops ticking. While this isn't exactly the strongest reaction in terms of damage, the fact that it allows both auras to exist simultaneously has a significant implication. When a third triggering element is introduced, that element can react with both Electro and Hydro to trigger 2 reactions at once. This is a very powerful mechanic. This is what enables the double swirls that Taser teams are often known for, and it's also the main driving force behind the Raiden national team. Raiden and Xingqiu respectively apply Electro and Hydro very frequently, which allows us to maintain the Electrocharge reaction on the enemy most of the time. When Xiangling's Pyronado comes around, it reacts with both auras to trigger Overloaded and Vaporize. When we add an Electro character to the standard national team, you would think it would create a kind of dilemma where the Electro steals some of Xiangling's reactions and we have to choose between Overloaded and Vaporize. But instead, this special double aura behavior allows us to keep those strong Vaporize reactions while also getting Overloaded reactions, basically at no added cost. And this doesn't even account for the extra damage we get from Raiden's on-field damage. Next, let's talk about Burning. When Burning is triggered, it doesn't immediately consume the aura element, but instead causes the Dendro aura to decay at 0.4 gauge units per second, similar to how Electrocharged works. On top of that, it also generates a new aura, which is known as the Burning aura. You'll notice that this new Burning aura looks similar to the Pyro icon, and it does behave similarly to a Pyro aura. You can trigger most Pyro reactions against it, such as Vaporize or Overloaded. But what's more interesting is that the original Dendro aura that was used to trigger Burning is actually still there, and it's hiding under the Burning aura. If you can completely consume the Burning aura before this underlying Dendro aura expires, you can actually resurface this Dendro aura to reuse it for another reaction. This property where the Dendro aura survives during a burning reaction is a key mechanic that enables a lot of Burgeon teams, especially ones that use a fast Hydro applier such as Ayato or Xingqiu. Burgeon teams often find themselves in situations where they accidentally trigger Burning instead of Bloom, which is the reaction that you actually want. But if I use Xingqiu's skill in this situation, the first hit triggers a Vaporize reaction which consumes the Burning aura completely and exposes that Dendro aura underneath it. The second hit of Xingqiu's skill reacts with this Dendro aura that's now exposed and triggers a Bloom reaction. Even though this Dendro aura was originally stolen from us by this burning reaction, we were actually able to get a refund on it and still trigger Bloom, while also amplifying our Hydro damage in the process. And this is thanks to the fact that the Dendro aura is conserved even while the burning reaction is ticking, which allows us to reuse that aura as long as our Hydro application is quick enough. And finally, we have Quicken. Quicken does have a reaction cost and consumes the aura element normally like most other reactions do, but it also generates a new aura, which is the Quicken aura. Just like how the burning aura takes on the form of a Pyro icon, the Quicken aura appears as a Dendro icon, and as expected, it can trigger most Dendro reactions. The only exception is that it can't trigger another Quicken reaction. As most of you probably know, applying Electro onto a Quicken aura instead triggers Aggravate. But what's more interesting is that when you do apply Electro onto a quickened enemy, the Electro aura is allowed to coexist with the Quicken aura. Now we're in a situation that we've seen before, just like with Electrocharged. If we introduce a third triggering element, again, it can trigger a reaction with both auras. But this isn't always the case. Sometimes we only get a Bloom reaction even though the Electro aura is present. To find out why, let's take a closer look at our aura consumptions. We're using a 1U Hydro trigger, and it first reacts with our Quicken aura to trigger Bloom. A Hydro Bloom has a reaction cost factor of 0.5, so we consume 0.5 gauge units from the Quicken aura. The key here is that there is still some of the Quicken aura remaining after this reaction happens. The Hydro trigger didn't have enough gauge units to overflow into the Electro aura. If we compare this to our previous example, the Quicken aura is a bit lower when the Bloom is triggered. Critically, it's under 0.5 gauge units. This means our 1U Hydro trigger is more than enough to deplete the Quicken aura, and the rest of that Hydro trigger overflows into the Electro aura to trigger Electrocharged too. Now this begs the question, why does Bloom get to trigger first, and Electrocharged only gets the leftovers of the Hydro trigger? This has to do with a concept known as simultaneous reaction priority. When a trigger element is applied to multiple coexisting auras, some of those auras have higher priority than others, and there's a predefined order in which those auras are consumed. If our trigger gauge is big enough to deplete the higher priority auras, then it can also react with the lower priority auras underneath it. In this case, the Quicken aura has a higher priority than the Electro aura. In the case of Electrocharge, the Electro aura has a higher priority than the Hydro aura. And speaking of these two reactions, Hyperbloom teams take advantage of both the Quicken and Electro double aura, as well as the Electrocharge double aura. By quickly applying Electro, a lot of Hydro, and Dendro in this order, we continuously move between these three states while triggering Quicken and Bloom in the process. Because it bounces back and forth between these two double aura states, it can trigger a lot more reactions than most other teams who utilize only a single aura. As demonstrated by the sheer length of this video, elemental gauge theory is a very dense topic, and this is even after I left out a lot of the finer details and advanced concepts. Even if you don't understand all of its details, even getting a basic handle on elemental gauge theory can help you view the game through a more conscious lens. It's a concept that shows up literally anywhere in the game where reactions are involved. Although it may feel pretty daunting to learn at first, now that we've broken it down into its smaller core concepts and sprinkled in a few visual aids, I'm hoping that it feels a little more approachable now. Regardless of how much you learn from this video or where you choose to apply it, as always, thank you so much for watching.